5.2 piecewise defined functions. Our essential question is, what are the key features of piecewise defined functions? By the end of this video, you will be able to graph and interpret piecewise defined functions. Let's start with piecewise defined functions. Piecewise, that is talking about multiple functions. Defined, that just means it's over certain x values. So we're only talking about our x values. Think of a function, each function separately, then list their domain, the x values, restrictions. Now, pause the video at any time you need to catch up with the notes. Let's evaluate f of x equals x plus 1 when x is less than or equal to 2, and f of x is negative 3 over 2 times x plus 5 when x is greater than 2. So if we need to evaluate f of 0, we first need to identify which inequality, where does 0 fall in line. Identify which inequality the x value satisfies. Is 0 less than or equal to 2, or is 0 more than 2? Well, 0 is less than 2, so we're going to use the top function of x plus 1. So to evaluate f of 0, we're going to plug in a 0 for the x and evaluate. We get f of 0 equals 1. Now, as a reminder, okay, we're going on to f of 2. 2 is equal to 2. So you see this line underneath? See how the 2 matches these both? So which one do we choose, top or bottom? Well, because we have this line underneath, that tells us that it could be equal. X can be equal. In this case, 2 is equal to 2, so we're going to use that top function again, and we're going to replace the 2 with the x. 2 plus 1, f of 2 equals 3. And we have one more function to evaluate, f of 4. We need to figure out, okay, is 4 less than or equal to 2, or is 4 more than 2? 4 is greater than 2, so we are going to use the bottom equation, the negative 3 over 2 times x plus 5. So we have negative 3 over 2 times 4. Remember, you can use a calculator here, but negative 3 over 2, well, 3 times 4 is 12. And 12 divided by 2 would be 6. So this would be negative 6 plus 5, which ends up being negative 1. Let's evaluate the same idea, but here's a graph of a piecewise defined function. So when we want to evaluate f of x, be reminded that the x value that you see inside, that number is the input value, which represents the x value. What you get out, what you put down as your answer is the output value or the y value. So we're going to evaluate the piecewise function graph over here. If I need to evaluate f of negative 4, the x value is negative 4. So on my graph, if I climb over here to negative 4, now I need to jump to my graph. Looks like I got to travel down to my graph. And I'm trying to figure out, okay, what's the y value at this spot? Well, the y value is negative 3. So again, my answer is going to be my output y value. So f of negative 4 equals negative 3. Let's evaluate f of 0. So when the x value is 0, we go up to our graph. So this time we had to travel up. We get this point right here. The y value is going to be our output, and our output here is 2. So f of 0 equals 2. Now our last one, f of 3. So if we go for an x value of 3, I go over here to 3, and I've got two choices. I could either go up here where I see an open circle, or I could go down here where I see a filled-in circle. This open circle means that the x value is not included, so we need to go down to this point where the x value is at negative 2. The open circle means the point is not included. The closed circle means that it is included. So therefore, our output value for this one would be -2. F of 3 equals -2. All right, we need to write a piecewise defined function for the graph. I want you to notice this vertical line here. I'm going to make a little red dotted vertical line. That is at an x value of 3. So much like here, when we have our less than 3 or more than 3, that was from the first example. This is where inequality, see how one graph is going to the left of 3 and one graph is only traveling to the right of 3. We're going to talk about finding this equation first. So I'm going to identify the slope. I see a point right here. And if I travel up this way, I see a point right here. So remember that it's rise over run. So we have a run of 3. Well, this would be -3. And a rise, right, of 2, or we could call it -2. So if we're going from left to right, we're going down 2 and over 3. I know I counted backwards, but be reminded that this slope would be -2 over 3. Now we need to identify the y-intercept. The y-intercept of this graph is at 5. So the equation for this graph would be -2 over 3x plus 5 when x is less than 3. Notice the open circle, so I don't need the line underneath. And that graph is going to the left, so you can think, okay, my x is going left of 3, if you think of that as an arrow. Now let's identify the slope of this line. So here's a point. If I travel along it, here's the next point. So it looks like we're going up 1 and over 1. So the slope is 1 over 1. And we're going to use that slope to find the y-intercept. So if I traveled this way 1 and this way 1, there's my next points. And it gets all the way down here until we cross at 4. So the y-intercept will be 4. The equation is going to be x plus 4, because we have a 1 over 1 slope. My y-intercept is 4, but the x values have to be greater than or equal to 3. So this green portion of the graph doesn't actually exist in our piecewise defined function. I just extended the line so I could quickly figure out what that y-intercept would be so that we could come up with our piecewise defined function. F of x is going to be -2 over 3x plus 5 when x is less than 3, and x plus 4 when x is greater than or equal to 3. Let's graph this function. Be reminded that 2 is where our vertical line is going to be. So one graph is going to go left of 2, and one graph is going to go to the right of 2. The top graph is going to go left. That's less than 2. The bottom graph is going to be more than 2, so that one's going to go to the right. So if we start with our top equation, we plot the y-intercept. The slope is 1 over 1. The y-intercept is 1. So we go 1, we climb up 1 to the right 1, up 1 to the right 1. Less than 2 means left of the red dashed line. We can use a closed filled-in circle because we have our equal sign here. And we can continue the graph traveling this way and be reminded that we can only go left of that dashed line of 2. Filled-in circle because of the inequality x is less than or equal to 2. Let's graph this one. Okay. Plug in 2 for the x in the equation. So here's the deal. We could go up to 5, but that part's not going to be part of the graph. If we want to figure out, okay, where is this graph going to start, the graph has to start somewhere along this x value of 2. So if we just plug in a 2 here, that will help us calculate this. Input x value, we calculate it out, our output is 2. So that means we're going to plot the point 2, 2 using an open circle because 2 is not included due to the inequality being x is greater than 2. So we can put an open circle here, and now from this point, we can count our slope of negative 3 over 2. So I can go down 3 and over 2. We get our first point there. There's our second point, and we can connect them. There is our piecewise defined function. Feel free to leave this dash line in, or you could take it away. I have it in right now as you're trying to learn. Making the graph, remember this is kind of the barrier. One graph has to go to the right of that barrier, the other graph has to go to the left. All right, let's do this. We need to write a piecewise defined function to represent the situation. We have the cost of custom wristbands order. Put your name here on these custom wristbands. You got options. If you order 0 to 50 wristbands, it's going to cost you $2 per wristband plus $5 shipping. If you order between 51 and 100, we'll charge you $150 each, $10 shipping. If you order over 100 wristbands, it'll be $1 for each wristband plus $15 shipping. So to write a piecewise defined between 0 and 50, it's going to cost us $2 times every wristband plus $5 shipping, and that happens when x is between 0 and 50. So x is less than or equal to 50 and at the same time greater than or equal to 0. 51 to 100 wristbands. Well, it's going to be $1.50 times every wristband plus $10 shipping. And that happens when x is between 51 and 100. And our last one is over 100. It's going to be $1 times x plus 15 for any number that is greater than 100. If you order exactly 100, it's going to cost you $1.50 per. So you need to order more than 100 to get this dollar discount. So I have our piecewise defined function from the previous page here. Here's our follow-up question. Marie thinks she wants 90 wristbands, but her friend says that ordering 129 will be cheaper. Let's evaluate each one and see. If we evaluate f of 90, that means we're using the middle equation. It's going to cost us $1.50 for each one. So $1.50 times 90 plus 10 would be $145. And let's find f of 129. Plug it in. Looks like it's going to be $129 plus 15. Oh, that math isn't right. I need it. It's going to cost us $129 for that plus 15. It's actually $144. So yes, it'll still be the cheaper option. It'll cost you $1. It'll be $1 cheaper to order 129 versus 90.